Hello everyone, welcome to this video. So in this video what we are going to do is to solve problems on definite integration. Now problems on definite integrals can be solved using various methods because of the vast number of properties they have, and in the previous lecture we have computed some of the definite integrals using known properties which were on the easier side. So that's the heading for today's video. Now let us begin with the first problem. Problem number 1, that is, so problem number 1 is minus pi to plus pi cos square x divided by 1 plus a to the power x dx. So what we are going to do is we are going to apply a bunch of various properties and we are going to understand each problem carefully, and at the end or in the next video what I'm going to show you is a special definite integral which would require certain different methods to be solved, which we also call the Feynman trick of differentiation or integration. And obviously in the other course of integration those things will be covered in much more detail than now, but this is just to give you an idea and to have you the necessary tools in order to solve all the problems from continuous random variables, joint random variables, and MGF and random processes. So whatever integration is necessary in order to do probability is being taught here as a supplement for this course, but only the details would be covered in the actual course. So if we first denote the integral by I, and now after denoting the integral by I, what we have is I equals to minus pi to plus pi cosine square x by 1 plus a to the power x dx. Now the thing is, if you remember the property, we recall that a to b f of x dx is equal to a to b f of a plus b minus x dx. So this was a property that was introduced in the beginning of definite integrals, where we proved this property as well, and it's a property which says that if you have an integral of a function f of x dx from limits a to b, that is same as integrating the function f with the argument a plus b minus x. So you basically replace x by the sum of the limits minus x, and that is also the same thing. So that's what we can do here, because here f of x is basically f of x equals to minus it's not the integral, sorry, f of x is equal to cosine square x by 1 plus a to the power x, right? So our limits here, a is equals to minus pi and b is equals to plus pi, right? Then f of a plus b minus x is simply f of minus pi plus pi minus x, or which is f of minus x, and f of minus x should be equal to cosine square of minus x divided by 1 plus a to the power minus x. Since cosine is an even function, so since cos x is an even function, we have f of minus x equals to cos square x by 1 plus, and a to the power minus x can simply be written as 1 by a to the power x. So if you do the LCM below, what you get is something like this: cos square x by a to the power x plus 1 by a to the power x. And if you take the denominator to the numerator, because there are two divides there, what you get as the final answer is a to the power x into cos square x by 1 plus a to the power x, right? So this is what we get. So we see that the value of the integral I, which was given as minus pi to plus pi cos square x by 1 plus a to the power x dx, is also equals to minus pi to plus pi a to the power x cos square x by 1 plus a to the power x dx. So as we can see here, there are two different representations of the same integral I in terms of two different functions. And since they represent the same value, what we can do is we can add those values. That is, what we can do is as follows: we can add and these two representations of I will then be I plus I would be equals to minus pi to plus pi cos square x dx by 1 plus a to the power x plus minus pi to plus pi a to the power x cos square x by 1 plus a to the power x dx. So if you keep on doing the equation, what you get is 2I equals to, now we can add both of the integrands because the limits are same and the integration variable is also same, obviously. So what we get is something like this: cos square x by 1 plus a to the power x plus a to the power x cos square x by 1 plus a to the power x dx. Therefore 2I is equals to minus pi to plus pi. Now since the denominator is the same, we can add the functions together and they give you cos square x plus a to the power x cos square x dx. In the numerator, we can see that we can take cos square x common, which gives us 2I equals to minus pi to plus pi cos square x into 1 plus a to the power x divided by 1 plus a to the power x dx. And this gives, these things cancel off, because since 1 plus a to the power x is greater than 0 for all x belongs to minus pi to plus pi, right? So neither in no point in the interval this thing is 0, so we can cancel it off, obviously, and therefore the thing becomes 2I equals to minus pi to plus pi cosine square x dx, right? Now we try to remember the properties of an even function. So let g of x equals to cosine square x and g of minus x is equal to cos of minus x whole square. But since we know cos is an even function, which is basically if you change the argument from x to minus x, it remains the same, it is also cosine of x. So this becomes cos square x, which is equals to g of x, right? So g of x equals to cos square x is an even function. For even functions, we know that minus a to plus a g of x dx should be equals to 2 times 0 to a g of x dx, right? This was the property for even functions. Therefore, if we apply that, if we are going to apply that property, what we get is this: 2i is equals to 2 times 0 to pi cos square x dx. Now the 2's cancel off on both sides and we get I equals to 0 to pi cos square x dx. Now what it remains is to calculate this integral, and this can be calculated as follows. Firstly, we use the formula 1 plus cos 2x by 2 dx. This is according to the formula that cos 2x is equals to 2 cos square x minus 1. So this is according to the addition formula or the multiple angle formulas, where you also have formulas for cos 3x, cos 4x. In fact, cos nx is a nth degree polynomial in cosine of x. So like that. Now this can be separated into two different integrals, that is 0 to pi half dx plus 0 to pi half cos 2x dx. Now the first part gives us pi by 2, and the second part of the antiderivative of cos 2x is sin 2x by 2, and that means we need to do sin 2x from pi to 0. So pi by 2 plus 1 by 4, we have sine of 2 pi minus sine of 0, both of which are 0 basically, because any integral multiple of pi of sine is 0. So we get the answer as pi by 2 because this portion is 0. So our final answer becomes pi by 2. So therefore we can write it here that minus pi to plus pi cos square x divided by 1 plus a to the power x dx is just pi by 2. So this is the answer, right? So I hope you understand the problem, because I wanted to show you it in extreme details possible, because this is the first time we are trying to do this kind of problems. So I hope it was clear to you. So in the next video we are going to do another problem. For then, thank you, and please do check the link in the description for the Breatter Maths app. Check it out yourself, because all the theories and video solutions are all provided in there. Thank you.